Hey, trig class, we're going to take a look at lesson 3.2, which introduces a radian measure of an angle. And so we'll jump in here. So it says, if you think back to the work that you've done in algebra, when we have functions that are in the form y equals f of x, you have x in there as your variable, where both x and y are real numbers. In other words, they're numbers that we could graph on the coordinate plane, but just using our normal set of real numbers. The trig functions that we've worked with so far have been in the form like y equals f of theta, where theta is measured in degrees. So in other words, like when we were solving some equations that had maybe like sine of theta equals 1/2, and then we were solving that, we were saying, okay, I know the angle, one of the angles that makes that true is theta equals 30 degrees, and then we'd have another angle where it would be 150 degrees and so on. But so in this case, theta was measured in degrees. So what we want now, it says, in order to apply the knowledge that we have about functions from algebra to trig, we need to write our angles as real numbers, because degrees aren't real numbers. That's kind of a made-up measurement that we talked about that was probably based on, maybe it was based on the number of days in the year, this approximately, to rotate the Earth around the sun. But what we want to look at is actual, real numbers that match up with, like our real number we had on this side of the equation. So another way to talk about the measurement of an angle is called the radian measure. And the definition of that is this. It says, in a circle with a central angle that cuts off an arc that's equal in length to the radius, that's called 1 radian of an angle. Of a measurement of an angle. Okay, so in other words, this length of the radius, so from here to here, so from center of the circle out to the edge of the circle, that's the radius of the circle. If we were to take that length, and if we could just wrap it around the arc of the circle, those two measurements would be the same, and then we would say that this central angle is 1, not 1 degree, but 1 radian. And you don't have to label it. If you just say you don't put the degree mark, then it would be assumed to be radians, but that's 1 radian is what we'd have there. Okay, and what it takes to get all the way around the circle, what we're going to find is, so if we had that same measurement, like if it was a piece of string and we kept wrapping it around, it would take just over 6 1/4 of those lengths to get all the way around. So it takes 3.14 of those lengths to get halfway around, which is pi. Okay, so 1 pi is actually half of a circle. That would be the same as 180 degrees. 6.28 approximately is 2 pi, and that's how many of these radius lengths it takes to wrap around the full circle. Okay, so that's going to bring us to our conversion that we're going to use. Now, it's not always going to match up that we're working with 1 radian for our central angle. So in other words, so to find the central angle in radians, the idea is that we take whatever that arc length is and we divide it by the radius, and that gives us our central angle in radians. So S is what we use for arc length, so that's this measurement. And arc length would be a measurement in like inches or something like that, or centimeters, but it would be whatever length, that was the same unit that we're using to measure the radius length in. Okay, but we can also in geometry, that you can talk about the measure of an arc as an angle as well, and it's the same as the central angle. Okay, we'll get to that. So it says a central angle theta in a circle of radius 3 cuts off an arc that's 6 centimeters. What's the radian measure of theta? So right here we're told that theta in radians is S divided by R, arc length divided by radius. Okay, so we've got theta can be found by taking S divided by R. Okay, so we've got theta equals, and in this case our S, the arc length right here, that's our arc length, S equals 6, and we've got the radius, S equals 6, and the radius is equal to 3. Okay, so we're going to take 6 divided by 3, and for this particular circle with this for this central angle, it would have a measurement of 2 radians. Sometimes you just stop with RAD, radians, but I'll just write it out here, 2 radians. Okay, and again, so that just means that the arc length is twice as long as the radius, so that's 2 radians. A radian is actually a radius measure just wrapped along the circle, and then the central angle that cuts off that arc length is that measurement in radians. Okay, so like we said, because one complete rotation around a circle is 360 degrees, that's also equal to 2 pi radians. Okay, if you think about the formula for finding the circumference of a circle, which is all the way around a circle, there's a formula that's 2 pi times the radius, right? Well, if we're thinking a radius of 1, that's just 2 pi, right? So therefore, here's what we've got. We've got 1 radian is the same as, now think about this. So if 360 degrees equals 2 pi radians, right? Okay, so if we want to convert from one to the other, if they're equal to each other, we can use them in what's called a conversion ratio, right? So, if they're equal to one another, you can multiply by the ratio where one is on top of the other one, and either way, right? So 2 pi radians like this, right? That's what we'd have. Now 360 and 2 pi, you could reduce 360 down to 180, and then the 2 in front of the pi would cancel, leaving you with 180 over pi. Now, when you use a conversion ratio, whatever you want to convert to, that's the way, that's the one that you put on top. So if I wanted to convert a radian to a degree measure, I'd multiply by 180 degrees over pi radians, okay? But if I wanted to convert the other way, because remember, these are equal to each other, I could put the 2 pi on top, and then the 360 on the bottom would reduce to pi over 180, okay? So if we want to convert degrees to radians like this, what we would do is we'd use this conversion ratio. What this means is there's, and usually you don't write the units on here, but there's pi radians, right there, that's trying to write radians, over 180 degrees, right? And so if I'm converting 30 degrees, I'd write 30 degrees over 1, and then the degrees technically are canceling out. It leaves me with, so I'd have like 30 pi over 180, and we just simplify that, right? 30 over 180, the zeros could cancel out. 3 over 18 reduces to 1/6, so that would be 1 pi over 6. Okay, so 30 degrees is pi over 6 radians, okay? You don't have to write the unit on that, but that's a radian measure. If you don't put anything after it, you talk about an angle, that means radians. Okay. Now, if you're going the other way and you want to convert radian measure to degree measure, then we use the conversion ratio the other direction with the 180, which is the degrees on top, and and the radians on the bottom. So if we were doing this the other way and we're saying, okay, let's convert pi over 6 back. So if I was taking pi over 6 and they said convert that to degrees, I'd multiply the problem out this way. So then the pi on the top and bottom would cancel. I'd end up with 180 over 6, and then I'd get 30, which would be degrees. And again, this would be degrees here. These are the radian measures that are technically canceling on the top and on the bottom. And so I'm left with degrees there. Okay. All right. So another radian measure that we would want to convert to degrees in this one. So I've got pi over 5, right? So it's pi radians over 5. I want to convert it to degrees, so that means I put the 180 degrees on top. Now 180 degrees is the same as pi radians. Okay, so that's your conversion ratio. Pi cancels. I'm left with 180 degrees divided by 5, and if I take 180 divided by 5, I'm going to get, so that goes in there 3 times 15, 30, so that's going to be 36 degrees. Okay. So here's just a table where we have some of our common angles that we work with all the time and converting those to radians. Eventually you're probably going to remember these ones because we use them a lot. Obviously 0 degrees is still going to be 0 radians. You multiply 0 times pi over 180, you're still going to get 0, right? 30 times pi over 180, we just did that one, and we got pi over 6 for that one. If you take 45 times pi over 180, you're going to get pi over 4. Okay. I'm not going to maybe work all these out because the math isn't very difficult. It's just taking a fraction and reducing it. 45, is going to go into 184 times, so you're going to have just pi over 4 for that one. And then 60, well, that's pi over 3 because 60 goes into 183 times. 90 is going to be pi over 2 because 90 goes into 180 twice. 180, well, that's just pi. That's our half circle. Okay, half circle is pi. 270, that one's going to be 3 pi over 2. And 360, that's a full rotation. That's 2 pi. Okay, so some of the real common ones. Okay, so when we start looking at our angles going around. So 0 obviously is 0. At our 90-degree mark, this is pi over 2. At our 180-degree mark, that's pi. At our 270-degree mark, that's 3 pi over 2. And then, again, a coterminal angle with 0 is 2 pi. That's full. We've gone, full circle on that one. Now, if we were to split this into our 45-degree angles in here, so 45 we said was pi over 4, right? And then if I go another 45, that's 2 pi over 4, but 2 pi over 4 reduces down to pi over 2. If I go another 45 degrees at 135, that would be 3 pi over 4. And then another 45 degrees is at 180, so that's like 4 pi over 4. Then I've got another 45 would be here, that's called 5 pi over 4. That would be at 225 degrees. Another 45 degrees would be at 270, and 270, we already did that one. That's like 6 pi over 4 if I keep going pi over 4, but that reduces down to 3 pi over 2. And then I'd have 7 pi over 4 right here. That's 315. And then 8 pi over 4 brings me to 2 pi. That's 360. So those are some common ones. Well, we can also fill in all the 30 and 60 degree measurements in there by counting, by pi over 6s all the way through, but I'm not going to do all that right now, but that's the idea. It's just, based on 360 being 2 pi, 180 being 1 pi for radians, okay? All right, in the last section, we talked about, using reference angles to find some trig ratios of different angles, but this time they're going to be in radian form instead of in degree form. Now, a lot of students are more comfortable just converting these to degrees right away and working with that, which is fine. But sometimes it's real easy because if you see, if I know that there's a 4 in the denominator, then that tells me the reference angle is 45 degrees. Okay, here are the basics. Okay, if we've got pi over 6, that's a 30-degree angle. So if there's any 6s like this, then I know my reference angle is a 30-degree reference angle. The 7 pi over 6 just tells me, well, that's got to be, 6 pi over 6 is 180, so it's got to be in quadrant 3. Okay, so if I've got pi over 3, that tells me that that's a 60-degree reference angle. So anytime there's a 3 in the denominator, like this one, I've got a reference angle that's 60 degrees. And if I've got a 4 in the denominator, like I just went through, that's a 45-degree reference angle. Okay, so 5 pi over 4, if I've got that one, remember, 5 pi over 4 is like 1 1/4, so 4 pi over 4, or pi, would be here, right? This would be pi. But if we're doing 5 pi over 4, that's another 45 degrees beyond there, right? So this is where my terminal side would be. It would be right here in the third quadrant, okay? And then I've just got like a 45-degree angle here, or a pi over 4 angle, okay? And then, so if that's the case, 45, 45, 90, then I know I'm going to write -1, -1, and root 2 on my triangle. So sine of that, opposite over hypotenuse, would just be, -1 over root 2. -1 over root 2, or negative root 2 over 2. Okay, but I know it's negative because it is in quadrant 3, and I should be able to figure that out by, 5 pi over 4. Now, if you want to convert it, go ahead and convert it. It'll convert into 225 degrees. Okay, so you can, if you want to convert that so it's easier to think about, you can do that. You just multiply it by 180 over pi and do the math. But if you have a little bit of fraction knowledge, if this is pi, which is 4 pi over 4, well, 5 pi over 4 is just one more, 45-degree rotation from there. Okay. All right, this one. Okay, so we've got 2 times cosine of 2 pi over 3. So let's figure out where 2 pi over 3 is. Again, so since it's over 3, I know that I've got, a 60-degree reference angle. Now, 2 pi over 3, that's like 2/3 of pi. That's, that's going to be somewhere in quadrant 2, because this is full pi at 180. So 2/3 pi is going to be, like I said, that's going to be in quadrant 2. So that's going to be a reference angle of 60, right? So we're going to have like 60 degrees right here. So short leg is 1, long leg is root 3, hypotenuse is 2. I'm going to put a negative on that side because that's going left, and then I'm going up to the point on the terminal side up here. Right? So cosine of 2 pi over 3 is going to give me adjacent over hypotenuse. Okay? So that's going to be negative 1/2, but then I'm multiplying that by 2. So I've got 2 times negative 1/2, so that's going to be negative 1 is my answer for this one. Okay? All right, and then the last one, 7 pi over 6. 7 pi over 6, okay. So pi over 6 right here, that's going to be a 30-degree reference angle, because pi over 6 is equal to 30 degrees. This is just 7 of those, right? So you've got 7 30-degree angles. That's 210 degrees if you want to think of it like that. Just like this one, pi over 3, you got 2 of those pi over 3 angles, 2 60-degree angles, that's 120. So that's why we're in quadrant 2. Now this one, we've got 5 pi over 4. Pi over 4 is 45. You got 5 of them. So 5 times 45, that gives you that 225. That's why it's here in this third quadrant. Okay. So when we draw this one out, 7 pi over 6, that's 210 degrees. Okay. 7 times your 30-degree reference angle. So that's 210. It's going to be like here. Okay. So I've got a 30-degree reference angle. I know that if that's the case, I got 1 here. I'm going to put a negative on that. Hypotenuse is 2. I got a negative root 3 there again. Okay, and I want to do tangent, opposite over adjacent. That's negative 1 over negative root 3, which is going to give me a positive 1 over root 3 for that. Okay. So that is doing just some trig ratios, giving the exact value. Exact value means don't type in your calculator. It's the ratio with the irrational numbers with square roots in the ratio. Okay, it looks like we got one more of these. Okay, this is just evaluating. So it's got an x in the expression. You're gonna replace x with pi over 6. So I've got 4 times sine of 2 times pi over 6 plus pi. Now this is all in parentheses, right? So we need to simplify this. So I've got 2 pi over 6 plus pi. Let's see how this simplifies then. So 2 pi over 6 is pi over 3 plus pi. Now, again, fractions, you need to have a common denominator. So I want a 3 as my denominator. And I've got pi, so this is going to have to be 3 pi over 3. Right? 3 pi over 3, pi, they're the same thing. Now I've got a common denominator. Let's add these up. So 1 pi plus 3 pi, that's 4 pi, right? So that's 4 pi over 3. I'm going to take the sine of that, and then I'm going to multiply that by 4. Okay. Now again, you see that there's a 3 in the denominator. Okay. But just from back here, when there's a 3 in the denominator, it tells me it's a 60-degree reference angle, right? So I've got pi over 3 is 60 degrees, and I've got 4 of those. So that's 240 degrees, right? 4 pi over 3 is 4 of these 60s, right? So that's 240. So 4 pi over 3 is going to be in quadrant 3 again. So when I draw this out, I've got a 60-degree reference angle. It's going to be in quadrant 3. So that's like a 60 right there. So opposite is the long side. So that's a negative root 3. This is a negative 1, and we've got a 2 here. So I want the sine of this 60-degree reference angle here that's in quadrant 3. Again, 4 pi over 3. So sine opposite over hypotenuse is negative root 3 over 2. So I've got 4 times negative root 3 over 2, which simplifies, this is like 4 over 1, so we can break this down. That's a 2, and then that becomes a 1. So that just becomes negative 2 times root 3. And that's it. That would be my answer for that one. Negative 2 root 3. Okay. So my hope is that when you're doing these radian measures, I know they might look foreign and confusing, but if you can remember these 3, then it's real, I think it's real easy to recognize that if there's a 6 in the denominator, oh, that's a 30-degree reference angle. And that's really all you're working with is the reference angles anyway. You just need to determine which quadrant it's in. So if it's 7 pi over 6, well, that's 7 times 30 degrees. So that's 210. You put it in quadrant 3. And always using like the 180, which is pi, as a reference too. If this is more than 1 pi, well, then you know you got to go beyond that. If it's less, you know, then maybe you're in quadrant 2. Half a pi is 90 degrees. So if you're okay with working with fractions, they're not too bad. That is all for this lesson, and we will continue on with the lesson 3 in class.